Last week, we learned vector cross product. People, by this vector cross product, we don't expect questions at the oral examination, but in term test, you will sometimes get. According to my memory, in 2020, the batch they are going to sit this time, February 7th, in their first term test under vectors, especially in the Kurunagala some schools, there were questions from this vector cross product. In the syllabus, people, this cross product is slightly introduced, but I discuss this vector cross product because this vector cross product is very important one after entering the university, whichever you do, physical sciences or engineering. And on the other hand, people, if you go the higher studies through the math stream, definitely you will come across this vector cross product, because especially for electrical engineering, electronic engineering, and in some ICT courses, you need this vector cross product knowledge. Okay, so therefore this knowledge will be very helpful in the future. Yeah, we are not going to sacrifice much time for this one. Today I supposed to discuss some properties of the vector cross product, and we come to the end of this too. Right, people, now under vector cross product, we just explain vector cross product like this. When we have two vectors like this, these two vectors, people, line on the same plane, and the angle between the two vectors is theta, right? Then this AB two vectors lie on the same, suppose, horizontal plane. Now this is the perpendicular line to the plane containing this vectors A and B. Then this line is perpendicular to both vector A and vector B. Then we define the A cross B, people, A cross B as modulus of vector A multiplied by modulus of vector B multiplied by sine theta times n. People, n means the unit vector in the direction perpendicular to the plane containing the two vectors A and B. There I told you to identify the direction of this n. When we consider A cross B, the left hand side first vector is A, then this edge we have to put on the vector A. So then this thumb, of course, pointing to a particular direction, right? That direction is the direction of this unit vector n, right? So there we further said this is called as vector product because the answer is a vector. On the right hand side, we have, this is a mod A is a value, real number, mod B is a value, real number, sine theta also a value that lies between -1 and +1. Then this product is a real number multiplied by a unit vector means, people, the right hand side answer is a vector. So therefore this result is a vector. That is why this is known as vector product or a cross product. Cross product and vector product mean the same, right? So now today, people, will write some properties of this cross product. Okay, yeah, I write down properties of vector cross product. Properties of vector cross product, right? Here the first one is this: A vector cross B vector is equal to minus B vector cross A vector. A cross B is equal to minus B cross A. What is this property? When we interchange the order of these vectors, right, extra minus sign coming. But people can remember in the dot product. In the dot product, we said what? A dot B is equal to B dot A. A dot B is equal to B dot A. Okay. A dot B is equal to B dot A. For the dot product, that's true. But cross product, that is not true. When we interchange the places of these vectors, extra minus sign coming. Okay. We can, with this improve, we don't supposed to prove this one. right? Just remember them, right? And number 2, write down first one, properties of vector cross product. A cross B is equal to minus B cross A. So therefore, remember, when we interchange the places, that means if you change the order of the vectors A and B, people, in taking the cross product, extra minus sign coming. Okay, right. This is the first one. Number 2, right? Number 2, people, suppose M is a real number, M times vector A cross N times vector B. This M and N are 2 real numbers like 2, 3. Then this is equal to M in, first we can multiply. You can first multiply M in and then take A cross B. These 2 numbers first we can multiply as usual. Right? For example, people, suppose we have 2A cross 4B. Then 2 and 4 you can multiply first, 8, then A cross B. 8 times A cross B. That's the second property. Okay? Yeah. Third property, people. Number 3, a distributive law. Distributive law. Number 3. Distributive law. This distributive law, people, has 2 forms. First is this, A cross B plus C. A cross B plus C, right? People, usual multiplication, usually when you remove the bracket, B plus C, before bracket we have A. How to remove the bracket? A times B plus A times C. The same way we can remove the brackets. But here, people, this cross means not the usual multiplication. It is cross product, because this notation cross the multiplication sign, here we are going to use between 2 vectors. Between 2 vectors, people, the usual multiplication sign, if we can write, but its meaning is, people, not the usual product. It is the vector cross product. Understood? Okay, right. So therefore, the distributive law is, people, first take A cross B plus, right, A cross C. A cross B, A cross C, this way, right? It's very similar to the usual multiplication method, right? But this cross is not the multiplication. A cross B plus A cross B, this plus coming, A cross C. Here we get that, right? The second form of the distributive law is, people, A cross B, A plus B. A plus B cross C plus D, this way, if we have A plus B cross C plus D. So how do we usually remove brackets when we have 2 brackets like this? In the same way we can write these 2. Understood? Then how to take that? A cross C plus A cross D plus B cross C plus B cross D. That way you can remove the brackets. Understood? That is called as the distributive law, right? So then we get A cross C, right, plus A cross D plus B cross C plus B cross D. This way. That is the distributive law. Right. Here was the fourth one. We'll take the fourth one. Right now, suppose let simple A and simple B be 2 vectors. right? A and B be two vectors. Now, if A cross B is equal to null vector, we don't say people A cross B is equal to 0. We don't say A cross B equals 0. We don't say like that. Why? A cross B means vector cross product. No. The final answer of cross product of two vectors will be another vector. No. Right? If that value of the vector is 0, it is called as 0 vector or null vector. There we have to use the word vector. If we just say people 0, if we just say 0 without saying the vector, 0 is the scalar. 0 is the scalar. Then A cross B result is a vector. If we say that is 0, vector will be equal to scalar. So therefore, people, whenever we need to say the size of the vector is 0, then we have to say 0 vector or null vector. And this underlined part of the 0 compulsory. Otherwise, this right hand side 0, if we don't have this underlined line segment, this one, people, this is just 0. That means a scalar. Vector is equal to scalar. That is impossible too. All right. Now, A cross B, when we find A cross B, it is null vector now, 0 vector. Then, in order to occur, when you take cross product between A and B vectors, when you take cross product between A and B vectors, the answer we get 0 vector. Then this can happen, people, subject to because of 3 cases. This can happen because of 3 cases. First thing is, to occur this, the reason may be vector A is null vector. Second case is vector B null vector. Or third case, people, the two vectors A and B are parallel. Because of one of those 3 reasons, this A cross B will be equal to null vector. Then people, suppose like this, for two vectors A and B, when you take A cross B, it is null vector. But we know that vectors simple A and simple B are not 0 vectors. Then subject to what condition this A cross B can be 0 vector? Then subject to A and B vectors are parallel. Because of the two vectors A and B are parallel, the A cross B will be equal to what? Null vector. So therefore, people, in this case, in order to show that two vectors are parallel to each other, we can use A cross B equals null vector or 0 vector. Understand? Right. Okay. Then write down, let A and B be two vectors. If A cross B equals null vector, then A is a null vector or B is a null vector or A vector is parallel to B vector. If this A is null vector, this A cross B will be 0 vector. If this B is null vector, A cross B will be null vector. Or if both this and this do not occur, when this A, B two vectors are not equal to null vector, but still A cross B equals null vector, mean this can happen now subject to A parallel to B. Okay, A parallel to B. Right. Right. Now people will write there as a star mark for the same thing. When A vector not equal to null vector, B vector not equal to null vector, but A cross B is equal to null vector, then what can we say? Then this implies that vector A is parallel to vector B. Vector A is parallel to vector B. Right. Next people, number 5. Number 5. Number 5. Fifth one. People, when we take vector cross product with the vector itself, A cross A, the two vectors are equal, A cross A. When you take the cross product with the same vector, people answer is 0 vector. A cross A, 0 vector. The reason can easily be explained, people. If we consider this say vector A cross A, how did we define? Modulus of A, modulus of B. B means still the same A. What are the angle between people A and A? Another line we have to draw to get the next A. Then angle 0. You know sine 0 is 0. In here, if this is 0, this whole product is 0. But when it is multiplied by this unit vector, 0 multiplied by any vector, 0 multiplied by any vector is not 0, people. 0 multiplied by any vector is null vector. That's how we say, right? So therefore you get null vector. That's why we say A cross A is null vector, right? Yeah. Now people, we can take the number 6. Number 6. Try to number 6. Right. Number 6 is this. Unit vector perpendicular to the plane containing A vector and B vector. Yeah. People, now we know A cross B. We define how, people? Modulus of A, modulus of B, sine theta n. Sine theta n. N is the unit vector perpendicular to the plane containing the two vectors A and B. You know this, right? People, now can you remember we wrote, people, AB vector is equal to AB vector modulus times U. What is U there? The unit vector in the direction of AB vector. People, then you can see here, when we get a vector like this, that vector can be written as its modulus times unit vector. Then really, people, in the left hand side, this vector, its modulus only available on the right hand side before this unit vector. This is the modulus of this vector. Like that, people, this n is a unit vector. Before this n, then this should be what? This mod A, mod B, sine theta should be, people, the modulus of this left hand side vector. Correct? No? We wrote this AB vector is equal to AB vector modulus into unit vector. Then on the right hand side, just before this unit vector, what is this? It is the modulus of this vector. Likewise, people, here, this is the unit vector, then this whole thing should be the modulus of this, modulus of A cross B. Understood? Okay. Then you can write this way. A cross B is equal to mod A times mod B times sine theta n. N is the unit vector. Then you can say, then A cross B mean what, people? Except this unit vector, the rest part. Mod A, mod B, sine theta. Right now? Then I can write A cross B what? A cross B is equal to this part is A cross B modulus times this unit vector n. Then this n can be subjected dividing both sides by this. Okay. Therefore, vector n is equal to what? A cross B divided by modulus of A cross B. Understand? So then A cross B modulus is, people, this. That is how we take the unit vector perpendicular to the plane containing the two vectors A and B. Understood? Right? Yeah. People, this all the theories. Another one more, number 7. We'll take down that too. Number 7. When I consider A cross B, its modulus is, people, what? Its definition is mod A, mod B, sine theta n. Then A cross B modulus is this part, mod A, mod B, sine theta. Also, we can write B cross A. People, we said B cross A is equal to what? We said B cross A is equal to, when we interchange the order of the vectors, we get minus sign, no? Extra minus sign coming. Also, B cross A, we said, people, we can write as minus A cross B. Then this minus A cross B, I can write A cross B is this, no? Mod A, mod B, sine theta n. This minus sign should be here. That minus sign I take, people, with this n like this. All right. Now, can you tell me what is the, this implies, what is the modulus of B cross A? What is the modulus of B cross A? Yeah, again, the last unit vector, it has minus. Minus n means what, people? If we consider n as upward direction, minus n means downward direction. Then this minus n means, people, in the opposite direction unit vector. So now, excluding this, when we consider this part, people, this should be the modulus of this vector B cross A. Then modulus of B cross A is what, people? Mod A, mod B, sine theta. Then you can see modulus of A cross B is mod A, mod B, sine theta. Modulus of B cross A also mod A, mod B, sine theta. These right hand sides are equal. Then, people, the left hand side must be equal. So this implies, people, what? This gives us A cross B modulus is equal to B cross A modulus. Okay. This all, people, the theories. Right now, we'll come to some questions. Right now, people take your tutorial. Right. Take question number 95, page number 19. Question number 95. Take question number 95. Question number 95. It's in on page number 19. Yeah. You are given a vector cross product. For any two vectors, simple A and simple B, define vector product, cross product, A cross B. You know that, people. A cross B is equal to what? Mod A times mod B times sine theta times n. What is this n? It is the unit vector which is perpendicular to the plane containing the vectors A and B. And its exact direction we know. How to define that exact direction mathematically, people? When a right-handed screw rotates from A vector to B vector, the direction of its head moves, right, is the direction of n. Right? How to find practically that one? If it is A cross B, starting with the vector A, this edge of the right hand we put on the vector A, then this thumb will point to a particular direction. Along that direction, the unit vector is the n there. So we know that. Okay, I'm not going to write that again. Okay. Let people now come to 95 part A. 95 part A. Question number 95 part A. Right. Question number 95 part A. ABCD is a parallelogram. Yeah. AB vector is simple A vector, AD vector is simple B vector. Show that ABCD area is A cross B modulus. Yeah, before people go into that, we must write as a note area of a triangle. First note is this. People, when we consider this way, a triangle ABC, right? Suppose this is theta, this height is h, or we'll take that as, yeah, we'll take it as h. So what is the formula for this triangle area, people? ABC triangle area? ABC triangle area is equal to half base into perpendicular height. Base is AB, people, this. AB, perpendicular height is h. Here we put usual multiplication sign. Half base into perpendicular height. People, can you remember this triangle when we consider this right angle triangle? No? A, C, and this. This is a right angle triangle, no? This angle is theta. This AC is its hypotenuse. People, using the hypotenuse and this angle, we know how to write this perpendicular height h. That means in a right angle triangle, using the hypotenuse and angle, we know how to write the opposite side. Can somebody tell me how to write the opposite side using the hypotenuse and angle in the right angle triangle? Yeah. Yeah. Hypotenuse times, we said opposite side, how to write? Hypotenuse times sine of this angle theta. Understand? Yeah. Sine. Yeah. Then you can write, but h equals AC sine theta. People, where did we learn this? Very first occasion we learned this where, people? Under trigonometry, can remember. Writing the two sides using hypotenuse and angle of a right angle triangle. So there you can remember in obtaining the AB formulae. We started from there, no? Yeah. Okay. Now I can put there, people, for this AB, this AC, for this H, this AC sine theta. Therefore, ABC triangular area is half multiplied by AB multiplied by H, means AC sine theta. AC sine theta. What is the formula? Half AB, this length, multiplied by AC, this length, multiplied by, in between AB and AC, what is the angle? Theta. Sine of this angle, theta. Understand? Right? ABC triangular area is equal to half AB multiplied by AC multiplied by sine value of the angle between this AB and AC. Understood? Right. That is the area of a triangle. You know this already, but you have to write down that. Huh? Yeah. Now, people, second note here, area of a parallelogram. Area of a parallelogram. Right. People, you know, if we consider this way, a parallelogram, A, B, C, D. If you drop a perpendicular from this vertex to opposite side like this, suppose this is H, and this angle is theta. What is this ABCD parallelogram area? It is, people, AB multiplied by H. AB multiplied by H. So side multiplied by the perpendicular distance between that side and its opposite side. Right? Opposite sides for parallelogram are, people, parallel. Huh? Yeah. But what is this H? H means AD sine theta. AD is the hypotenuse. This is theta. Opposite side is AD sine theta. So therefore we can write AB multiplied by AD sine theta. This is the area. These two results we need, people, in taking the answers here. Okay, right. Now, take down these two. Now we'll come to 95 part A. 95 part A. Right. First, take down these two notes. Right now, yeah. Now I erase this all. Okay. Okay, people, now ABCD is a parallelogram. ABCD is a parallelogram, right? Like this. I take the parallelogram like this. This is our parallelogram, right? Okay. AB vector given as simple A, and people, AD vector given as simple B. Let this angle be theta. Right. People, shall we define A cross B. What is that? Mod A, mod B, sine theta n. Then I am going to take A cross B modulus. Except this part, this is the modulus, no? Mod A, mod B, sine theta. Really, what is people mod A? Mod A means AB length, no? AB vector only, simple A vector. Then mod A means AB length. AB length. Mod B. B is this vector, AD vector. Then mod B means AD length, sine theta. People, what is this? AB, this side, multiplied by this side, sine theta. In the previous note, AB, this side, AD sine theta means people this perpendicular height. AB multiplied by this perpendicular height gives us ABCD, this parallelogram area. ABCD parallelogram area. So therefore, people, this is ABCD parallelogram area. It is given by A cross B modulus. A cross B modulus. Understood? Right. Yeah. Take its part B, people. Take its part B. Right. Try this part B. ABC is a triangle. ABC is a triangle, right? Its AB vector given to be simple A vector. This is simple A vector. And AC vector is simple B vector, right? Okay. All right. Let this angle be theta. Asking to show what, people? ABC triangle area is half A cross B modulus. People will take half. We'll first take A cross B. What is A cross B, people? Modulus of A, modulus of B, sine theta n. Then what is the modulus of A cross B? Modulus of A cross B mean, people, except this n, this whole thing. Mod A, mod B, sine theta. Then I am going to write, I multiply both sides by half. Then we get half A cross B. Half mod A. Modulus of A means, people, A is this vector, no? Its modulus means AB length. AB length. Half multiplied by AB length. Mod B is, people, AC. Sine theta. People, what is this? Half AB is base. Half base. What is AC sine theta? AC is this. AC sine theta means this height, no? Then what do you have here? Half base into perpendicular height. What is that? It is the area of a triangle. Area of this triangle. So therefore, what is this really? This part means ABC triangular area. So therefore, ABC triangular area is equal to this. Then ABC triangular area is this. Then finally we get the answer this way. ABC triangular area is half modulus of A cross B. That way we can take the answer. Right, people? Yeah. Let me take its third part. 95, part 3. That means part C. Right? Yes. ABCD is a parallelogram. The diagonals AC and BD intersect at O. ABCD is a parallelogram given. ABCD is a parallelogram, right? This is our parallelogram. This is our parallelogram. A, B, C, D. Right. It's AC. C is a diagonal. BD is not a diagonal. They intersect at O. Given now, right? Yes, people. AC BD diagonal intersect at O. Vector OC given as simple A, people. OC vector means this. O to C vector this. This is simple A vector. And OD vector is simple B. This vector is simple B. Okay. Then ask in what, people? Show that the ABCD area. ABCD area is equal to 2 times modulus of A cross B, right? Now, people now see here, when we consider this way a triangle, ABC triangle area, to take the ABC triangle area, what should be taken? Half. Take 2 sides of the triangle and take the 2 vectors. The 2 sides represent here, 2 sides are AB and AC. The 2 vectors available around AB and AC are simple A vector and simple B vector. Then ABC triangle area is half modulus of A cos B. Like that, people, suppose we have a triangle like this. This vector and this vector given. Suppose this vector is P vector, this vector is Q vector. Then what is this area? Area is half modulus P cross Q. Understand? Half modulus P cross Q. Right. Now, people, you can see here this OCD triangle. When you consider how to find the area of this OCD triangle, it is by using this property. OCD triangular area is equal to half. Take the 2 sides is 2, half modulus A cross B. Understand? Then we get this OCD area. People, you know, when we consider this way a parallelogram, these 4 triangles, OCD, ODA, OAB, OBC, these 4 triangles are equal in areas. Their areas are equal. How? Very simple proof, people. Yeah, very simple proof. I'll explain that too here. It is simply proved this manner. When we consider, people, this way a triangle, parallelogram. One property of a parallelogram is, you know, the diagonal bisect each other. The diagonal bisect each other. These 2 are equal. These 2 are separately equal. If I take this as AB, CD, right? This is suppose E. I drop a perpendicular from this D upon this AC diagonal like this. Suppose this is H. Can you tell me, this is the point E, AED triangle area. It is half, base is AE, perpendicular height is H. Right. Tell me, what is this CDE area? That is half, base is this time EC or CE. For that one, the perpendicular height is still this. You know, people, when we have our triangle like this, right? What is the perpendicular height to this base from this vertex? Drop a perpendicular like this. Produce this line. This is the required height. Then the area going to be, if we take this as ABC, ABC area is half. This is the base. AB, this is the height H. Understand? Using that, again, you can write area of this CED. Okay. CED area, half CE into this H. You can very clearly understand, people, this A to E length and E to C length being equal because this is a parallelogram. So therefore, this figure and this figure being equal. So therefore, what can you say? This answer and this answer. The rest ones are the same, no? This middle two are also same. Therefore, this whole thing and this whole thing being equal. That means these two areas being equal, right? Then you can write AED triangular area is equal to CDE triangular area. That is okay. Similarly, people, I drop a perpendicular like this to this. Okay. Now, you can very clearly see here, if I take, people, this angle as theta, then what is this H? This H means the opposite side of this angle theta. What is the hypotenuse? AD. Then what is this H? H is AD sine theta. Right. You know, when this is theta, this is also theta. By what? Alternate angles. These two are parallel, no? People, then what is this height? That height is what? BC sine theta. This is BC sine theta. But you know, this BC and AD are equal because opposite sides of a parallelogram. Then I can write AD here. Then you can see what, people? This is AD sine theta. This is also AD sine theta. That means what? This also H. Right. Now I can write what, people? AEB area. What is that? AEB area is half, base is AE, perpendicular height is H. Right. And next one, CBE area. It is half CE into perpendicular height is this H. See, people, again, what do you get? This AE and CE equal. AE, CE equal. Therefore, these two areas also equal. Then this area equal. The same figures only, people, here also we have. Therefore, these four triangles equal in area. Now, people, in this parallelogram also, these four triangles equal in area. Understood? So therefore, to find the area of this ABCD parallelogram, we'll find the area of this triangle OCD, and we have to multiply that by 4 to get the area of the triangle parallelogram ABCD. Understood? Yeah. Then you can write, people, like this. Then I think you could understand this one. If you need, you can take a note there, right? Then here I can write A, B, C, D parallelogram area is equal to 4 times OCD area, OCD triangular area, 4 times OCD triangular area. People, how to obtain the OCD triangular area? Now today we said, if we know 2 sides of a triangle, taking the cross product of that 2 sides and modulus and dividing by 2, we get the area of this triangle. Therefore, OCD area is what, people? Half modulus 2 sides of this triangle going to be A cross B. OCD area only this. Then 4 into this half means 2. Then we get ABCD parallelogram area 2 times modulus of A cross B. 2 times modulus of A cross B, right? Yeah, that is the answer. Right, now people, it's part D. I leave as homework. Little bit you have to think to take that answer. You have to think a little bit to take that answer, part D. ABCD is a quadrilateral. AC and BD are its diagonals. Show that ABCD area is this, half modulus AC vector cross BD vector. Yeah. Do that as homework. I'll come to people part E in it. Part E. Take part E in it. Take part E in it, right? Part E. The position vectors of the points A, B, and C of the triangle ABC are simple A vector, simple B vector, and simple C vector respectively. Yeah, this way, people. This is our ABC triangle. Right. Position vectors at the points ABC given as simple A vector, this is simple B vector, this is simple C vector. People asking, show that the ABC area, show that the ABC area, right, people? ABC area you can write how? ABC triangle area is equal to how, people? Half modulus what? Take 2 sides of the triangle and get the vectors representing by that 2 sides considered. I take as my 2 sides, one side as AB, other side as AC. Then ABC triangle area is equal to half modulus AB vector cross AC vector. This way. Right. People, how to write AB vector? Using the position vectors, we can write AB vector. How? AB vector is written how? Ending point position vector minus starting point position vector. Right? You know that. Now we'll write half ending point position vector is simple B minus simple A, B minus A, cross AC ending point position vector, simple C vector, minus A, simple A. Okay. Now people, we can simplify this. You can apply that distributive law we learned. How to remove the brackets? B cross C. And here plus and this is minus, no? Plus minus minus B cross A. Right. Then this and this minus plus product is minus A cross C. And this and this minus plus A cross A. That way you can remove the brackets by using the distributive law. Understood? Okay. Then see what we get there. Half B cross C, right, plus minus minus B cross A, right. I write this within the bracket, this within the bracket, right. Minus plus make minus A cross C, minus minus plus A cross A. All right, this way, huh? People, you know, we learned today A cross A. When you take the cross product of a vector with itself, the answer is what? Zero vector, not zero, zero vector. This is zero vector. Right, like this. Huh? Now, this B cross A, I can interchange the order of the vectors. B cross A, I can write as A cross B. Then you know, when we interchange the order of the vectors of the cross product, people, extra minus sign coming. Then I can write this as minus A cross B. Also this as minus C cross A. Minus C cross A. Understood? Then we get the required answer. Okay? Right. Right? Then we get that as half, right? B cross C, and they are plus coming. No, why people? We change the order of this B cross A to A cross B, another minus sign coming, that minus and this minus make plus A cross B. Right? And here also we change this. A cross C we write as C cross A. Another minus sign coming, that time this make plus C cross A. Plus C cross A. Right. Now people, you know, vectors, when we add the vectors, by any order, the vectors can be added. Now here this B cross C is a vector, A cross B is a vector, C cross A also a vector. That three vectors we can add in any order. So therefore, I can write the same thing like this. Half modulus, first I write A cross B, then I write secondly this B cross C, then C cross A. This way we get that answer. What? ABC triangular area. Okay. Right, people, now we'll come to the next one. Question number 96. Take question number 96. Right, question number 96, right. I'll give you 2 minutes, people, just try this question number 96. 96. Right, number 96. The angle between the vectors A and B be theta. Theta is in between 0 and pi, including both. The unit vector perpendicular to the plane containing the vectors simple A and simple B, moving from A to B is K. Correct. Show that K is this. That's very easy part, no, people? It says, people, this way. The two vectors are like this. Then the perpendicular vector to both A and B. Theta. And can you understand this? Can you clearly understand this diagram? Yeah, right. If I draw that in another way, I think you can get a clear diagram like this one. This vector is perpendicular to both A and B. Okay. Then people asking the unit vector K. How to write, people? A cross B you can write mod A mod B sin theta K. Then K can be subjected taking this all to left hand side denominator, and then A cross B divided by mod A mod B sin theta is equal to vector K. Right. So then this equals K means you can write this. A cross B divided by mod A mod B sin theta. Right. Right. Okay. We will show also that A cross B modulus perfect squared plus A dot B perfect squared is equal to mod A squared mod B squared. People, A cross B modulus means what? A cross B modulus means except this part. Okay, unit vector, the rest part A mod B mod sin theta is the A cross B modulus. Mod A mod B sin theta, right? Then A cross B modulus perfect squared means you have to square this right hand side. In this right hand side, mod A we have to square, mod B we have to square, sin theta we have to square. Then what do you get? Mod A squared, mod B squared, sin theta squared means, people, sin square theta. Let us take this as number 1. Okay, right. Secondly, A dot B. People, what is A dot B? The definition of A dot B is what? Modulus of A and modulus of B cos theta, no? Cos theta. A dot B is scalar product, vector dot product. By vector dot product, people, we get a scalar. Answer is not a vector, it is a scalar. Yeah. Now, what is A dot B squared? Square this, square this, square this. Mod A squared, mod B squared, cos theta squared means cos square theta. This is number 2. Now, what is asking, people? A cross B mod perfect squared plus A dot B perfect squared. People, we add this 1 and 2. We'll add 1 and 2. 1 plus 2. How to add 2 equations? Left hand sides we add separately. Right hand sides we add separately. Yeah. When you add the left hand side, what do you have? A cross B mod perfect squared plus A dot B perfect squared. Right hand side, when you add, people, here we have mod A squared times mod B squared. Here also we have mod A squared times mod B squared. That is common for both. Take that out. Mod A squared, mod B squared. When you take out, here we have sin square theta. And from here, people, we get cos square theta. But you know sin square theta plus cos square theta, this is 1. Then we get this into 1 means mod A squared times mod B squared. This is how we get the answer, right? So here we have this part, no? A cross B mod perfect squared plus A dot B perfect squared. This way we have, right? Yes. Okay, people. Right, people will take question number 97 as the next. Take question number 97 as the next. All right? Question number 97. Take question number 97. Right. Try this question, people. I'll give 5 minutes. Try this question. 97. Yeah, question number 97. If mod A is 2, that's on part A. Mod A is 2, right? Mod B is 5. And people, A cross B module is given as 8. Asking A dot B answer. Asking A dot B answer. Right. People, what is A cross B? A cross B given as 8. What is A cross B modulus given as 8? Then what is A cross B modulus? A modulus, B modulus, sine theta is 8 equals 8. A modulus is 2 multiplied by B modulus is 5 multiplied by sine theta equals 8. This 2n, this 8 we can cancel by 2. We get 4 there, right hand side. Then we get sine theta equals 4 by 5. Right. For the sine theta, people, I am going to draw right angle triangle like this. This is theta. Sine means what, people? Opposite side divided by hypotenuse. Opposite side is 4, hypotenuse is 5. Then by using the Pythagoras theorem, you can find the adjacent side. If you take this to be x, you know x squared plus 4 squared is equal to 5 squared by the Pythagoras theorem. Then you can subject x squared, take it to the right hand side, 5 squared minus 4 squared. This is 25, this is 16, this is 9 therefore, people. Then x is 3. This is 3. Right? Now you can write cos theta. Cos theta means adjacent side 3 divided by hypotenuse 5. Then asking A dot B. What is A dot B, people? How do we define A dot B? Modulus of A, modulus of B, cos theta is the A dot B. That is why we found cos theta from here, people. Mod A, it's 2. Mod B, it's 5. And cos theta, people, 3 by 5. 5 and 5 you can cancel down. 2 and 3 product is 6. Therefore, A dot B is 6. Right. Yeah. Come to its part B, people. Take part B. Take part B. Part B. Modulus of A is 10. Modulus of B is 2, right? And given A dot B as 12, and asking people A cross B modulus. Asking A cross B modulus. Yeah. Now I think you can take this answer. Right. A cross B, A dot B is what, people? The definition of A dot B is mod A, mod B, cos theta, no? A dot B given as 12, mod A is 10, mod B is 2, cos theta, 2, and this we can cancel down. This is 5, this is 3. Cos theta is, people, 3 by 5. If cos theta is 3 by 5, people, here, when cos theta, the first part is cos theta 3 by 5, no? Then for this, what is sine theta? Opposite side by the hypotenuse. We need sine theta to find A cross B modulus. Therefore, sine theta is what? 4 by 5. Then what is A cross B modulus? Mod A, mod B, sine theta. Modulus of A is 10, modulus of B is 2, sine theta is 4 by 5. Here you can cancel down. This is 16. A cross B modulus is 16. Right. Right, we will, as the next question, take question number 102. 102. Take question number 102. Question number 102. Can read that question, people? Right, question number 102. Right? It says in the triangle ABC, right? In the triangle ABC, BC vector, this one is simple A vector, CA vector is, people, simple B vector, AB vector, simple C vector. Right. And we are given modulus of simple A vector is A, modulus of simple B vector is B, modulus of simple C vector is C. Right. Prove that vector A plus vector B plus vector C is equal to null vector. Okay. People, now to get the first answer, here, people, by this way, we are going to prove the sign rule we learned in trigonometry by using vector cross product. You can remember we proved the cosine rule using the vector dot product. Using the vector cross product, we can prove the sign rule for a triangle. We proved that sign rule, no? Not proved, we used the sign rule. Right? Yeah. Now, here, people, when we use the standard notation for a triangle ABC, this angle is A. This angle is B. This angle is C. Right? Now, if I use the triangle law of vector addition to this triangle ABC, we can write, people, this way, no? BC vector plus CA vector is equal to BA vector. Now we'll apply triangle law of vector addition to this triangle ABC. I can write by using triangle law of vector addition. What do you get, people? This BC vector plus CA vector is equal to BC plus CA is equal to BA. Right. People, now BC vector over there, simple A. CA vector, simple B. BA vector, A to B vector, simple C. Then BA vector is minus simple C vector. Now I can take this minus simple C vector to this side. Then we get vector A plus, vector B plus, vector C. Once you bring this to this side, right hand side we don't have any vector. It is, people, zero vector. We don't say right hand side zero. No, zero vector. Right? Yeah. Right now, people, first part we proved. Yeah. First part we proved. Now, asking these people, hence prove that A cross B equals B cross C equals C cross A. Then to prove that one, people, this is what we do. Now we take like this. A plus B plus C vector is equal to 0 vector. Now both sides of this, left hand side is a vector, right hand side also a vector, they are equal now. Now I take both sides cross product with vector simple A. Vector simple A, we take the cross product with vector simple A. And then you can write, taking cross product taking cross product on both sides with simple A vector, like this. A cross A plus B plus C vector equals A cross null vector. People, whenever we take cross product with null vector, how define this, people? A cross null vector, modulus of A, modulus of null vector, sine particular angle come in, n also come in. Whichever this takes, this takes, this takes, this one, people, 0, no? Modulus of null vector is 0. Then this whole thing, finally we have to multiply by 0. Since here we have unit vector, 0 into unit vector means, people, answer is null vector. Right? So therefore here, this is null vector. Now you can remove the brackets by using that distributive law we learned. That is the usual way of removing the brackets. Right. And then what do you get? A cross A coming plus A cross B coming plus A cross C coming. Right. Yeah. Then we get, people, what? A cross A plus A cross B plus A cross C. Okay. People, we learn today, when we take the cross product of a vector with itself, answer is 0 vector. So this is that. A cross A is 0 vector. Then what do we have, people? A cross B plus A cross C is equal to null vector. So then, taking this A cross C to right hand side, people, what I get is this, no? A cross B is equal to, take this A cross C to right hand side, that will be minus A cross C. Once you take this right hand side, it is minus A cross C. People, we can interchange this order of letters. Then another minus sign coming. That minus and this minus together plus. It is C cross A. A cross B is C cross C, number 1. This is number 1. Secondly, people, what we do is this. Both sides of this, we take the cross product with vector simple B. Right? Then we take that one too. Write down that. Taking cross product on both sides with simple B. Again, A plus B plus C is equal to null vector. Taking cross product on both sides with simple B vector. What do you get? B cross A plus B plus C is equal to B cross null vector. Now remove the bracket. B cross C plus B cross B plus B cross C. Right hand side, people, we have 0 vector. Again, this B cross B is null vector. Right? Now, I take this right hand side, that will be minus B cross C. This A cross B, people, I can write as minus, sorry, this B cross C I can write as minus A cross B. Why? You know, people, when we interchange this order of the letters, we said minus sign coming, extra minus sign coming. This minus sign came, people, because we took this to right hand side. That's how this minus sign came. Now these two minus signs you can cancel down. Then here we have what? A cross B is equal to B cross C. This is number 2. Number 2. See now here, in number 1, A cross B is equal to C cross C. In number 2, again the same A cross B here, equal to B cross C. Then what can we say? This is equal to this. This is also equal to the same thing. Then what can we say? This equals what? This. Correct, no? X equals Y, Y equals Z. What do you understand by that two relations? X, Y, Z, all three are equal. Like that, this equals to this. This also equal to the same thing, this. Then this 3 are equal. Therefore, we can say by 1 and 2, the required answer we get. By 1 and 2, we get A cross B is equal to here, B cross C is equal to what, people? C cross C. Right. This is how we take that answer. Right. Okay. Now ask another one. Right. Now, people, here, A cross B is a vector. This vector is equal to this vector. That is equal to this. When two vectors are equal, people, you know, the modulus of that two vectors are also equal. When two vectors are equal, you know, the sizes are equal, directions are equal. Like that, people, this is a vector, this is a vector, this is a vector. These three vectors are equal. So therefore, the moduli values, moduli means the plural of modulus. Moduli values, that means sizes of the three vectors must be equal. That means modulus of this is equal to modulus of this equal to modulus of this. Understand, right? Yeah. And then you can write that one. We are going to the next answer. Right. You can now write, people, since A cross B is equal to B cross C is equal to C cross A. Since these three vectors are equal, their modular values are also equal. This implies what? Modulus of size of this vector is equal to size of this vector is equal to size of this vector. Right? People, when we consider A cross B, when we consider A cross B, right? Vector A is this, vector B is this. People, when we write cross product, we know the arrows should start from a point. Arrows should start from a point. In that instant, the angle between these two vectors, only the angle we take to write the cross product. So therefore, here, say the two arrows are going out. Then people, here, when we need to write A cross B, the angle between A and B is not this C. Then what? We have to produce this A vector so as to go out from this C like this. The arrow coming out this way. Then this is the angle. We have take in the A cross B. It is nothing but 180 minus C. Yeah. Then what is this A cross B modulus, people? A modulus, B modulus, sine 180 minus C. Like that, we can write this also. B modulus, C modulus between B and C, people, here. This is B, this is C. The angle is 180 minus C. The angle is 180 minus C. Sine 180 minus C. Next one. C cross A. C modulus, A modulus. What is this angle? This angle is the one we have to take, 180 minus B. Sine 180 minus B. Sine 180 minus C means what, people? Sine C. Mod A given as simple A. Mod B given as simple B. Then AB sine C here. Here, BC sine 180 minus A means we learned in trigonometry sine 180 minus theta is sine theta. And here what do you get? C A sine 180 minus B is sine B. Right. People, now this three equality, that means three equal figures, we divide by the ABC product. Divide by ABC product. Then when we divide this AB sine C by ABC product, This also by ABC product. This also by ABC product. Huh? You can see this AB and this you can cancel down. This BC and this you can cancel down. This CA you can cancel down with this. Then what do you get? Sin C by C equals sin A by A equals sin B by B. What is this, people? Sin A by A equals sin B by B equals sin C by C. What is that? The sine rule we learned in trigonometry. Then this gives us the required answer. This gives sin A by A is equal to sin B by B is equal to sin C by C. This is how we take that answer. Right. Right, people, now some more questions I supposed to do when we do some questions under that revision just before the examination. Your examination means in the term test. Now I'll roughly introduce another one thing, that is the three-dimensional space vectors. This you should know just. But people in nowadays, nowadays means long before, no, we are now some old people, no. In nowadays people, this vector lesson, of course, not stopped here. Furthermore, we had some more things called as vector triple product, something like this. A dot B cross C, vector triple product, and space vector. And in the university, you will discuss another applied maths lesson called as vector space. This vector is, people, very huge area. Right. Now, next one is, people, now suppose that three-dimensional space. Three-dimensional means what, people? Now, for example, I think this answer is correct. We finished that one. Right. Now, when we consider this board, right? When we consider this board, I'm going to draw on this board the x-axis and y-axis. The x-axis and y-axis like this. This is x-axis, negative x-axis, y-axis, negative y-axis. This is O. Right. Now suppose here we have a point P on the board. Somebody is at O. This person at O need to go to the point P. People, tell me, how many data must be given to this person at O to reach the point P? Only two data. What are the two data? When we drop a perpendicular from this P to x-axis and P to y-axis, right? This length and this length. That means this length, x and y. Enough for this person at O to find the location of P. Then how many data used? Two data, x and y. Distance along x-axis and distance along y-axis. So therefore, this way, a point on this plane is known as two-dimensional. Two-dimensional. Two-dimensional mean, people, having only this length along x-axis and length along y-axis, having this x and y, any point on this plane, anybody can find. Two-dimensional. We will now suppose this way. Suppose the point P comes out from the board. The point P comes out from the board. Now the man is at O. The point P comes out from the board, right? From here, point P comes out from the board perpendicular to this board. That means, suppose I'll take point P is coming out perpendicular to this board this way, and point P is suppose now here. Right? Now, how many data should be given to that person at O to reach this point? 3 we need. People, first of all, that person should be given these 2 data to reach the point P. From there, this person should be given, people, the distance he must come out from the board perpendicular to the board. To give that distance, people, another axis we need, like here xy, another axis we need. People, that axis is called as, people, Z axis. That axis is coming out of the board like this. Understand? Then the previously this point P was on the board. Now it came toward the space. The point P is now the space. Now to explain the position of a point in the space, people, now only these 2 data x and y not enough. In addition to that, another distance we need. That axis, of course, people, coming out from the board, that is called as a Z axis. Understand? So therefore, if I draw that one now, showing this 3 axes, now there are 3 axes called as x, y, and z. X, y, and z. The 3 axes x, y, and z. Then usually that 3 axes, people, we draw this way. This is x axis. This is y axis. This is y axis. This is x axis. Here the angle is 90. And z axis is, people, here like this. This is the z axis. This is how we draw the 3 axes in the plane. So this z axis, people, is perpendicular to both this x and y axis. Here this is 90 and this is 90. So this is negative x axis, negative y axis, and this is negative z axis. Then the point P, how to find, people? Point P, when it is on the OXY plane, this plane, point P, suppose here we have point P. Then this is the distance along x-axis to the point P, right? And we also drop a perpendicular like this, right? This is the y distance. Then the coordinates at P is xy. Now, away this point P on the plane, the point P now, after coming that out from the plane, it goes up a height. This is now, people, the Z coordinate. So therefore, if the point here is Q, Q has the 3 coordinates x, y, z. Understand? X, y, z. So now to explain the point Q, we need, people, at least 3 data, the distances along x-axis, y-axis, and z-axis. That is why we say in the space a point. is three-dimensional. Three data we need to explain that position. Now you know along x-axis, the unit vector we took as I, y-axis it is j people. Like that, along z-axis, the unit vector we take as k. Understand? About this k people, you should know something. Okay? And in nowadays people, the lesson continued from here also furthermore. I, j, k, three unit vectors with cross product and what dot product. But in your combined math syllabus, that part is not included. Very sorry for that, huh? Because people, there are lots of beautiful places in maths to learn when we continue this way furthermore. Maths is a very nice subject. Yeah. Write down people the next heading as three-dimensional space. Three-dimensional space. Three-dimensional space. Right. We'll write people a small note. Yeah, here this angle is 90 people. Here also this is 90. This is 90, right? Okay. Write down like this. Write down when a point considered, when a point considered on a plane to locate the position it is sufficient to know only two data namely the distance along x-axis and the distance along y-axis. Right, so draw this diagram. First diagram. For this point P, x comma y. Okay, now write down people. Suppose that this point comes away from the plane perpendicular to the plane. Comes away from the plane perpendicular to the plane. Now, to locate the point, we need another data. We need another data. The distance moved, people write down the perpendicular distance moved, right? The perpendicular distance moved away from the plane, away from the plane. In order to measure this distance, we need another axis. We need another axis. We need another axis, full stop. Write down. This axis is called as Z axis, capital Z axis. Capital Z axis, called as capital Z axis. With the unit vector simple k, within underline that, with the unit vector simple k along the axis. Along the axis. People now draw this second diagram. K minus y means minus j unit vector along this direction. Here minus I unit vector. Here minus k unit vector. Right? Yeah. Draw this diagram. This is really simple, is it done? Right. Now people, after this, we'll write another one sentence. Write down. Here, to explain the position of the point Q, we need three data, namely simple x, simple y, and simple z. Therefore, a point in the space is called as three-dimensional. Okay. Right. Even now, the point is moving in the space. The point is moving in the space. Say an aeroplane is moving. People, this variation, now x, y, z, all three will vary. In addition to that, people, this variation we can consider with the variation of time, right? Now people, see here, now I am resting here, but the time is elapsing, no? Time is elapsing, time is moving. The time is, people, another dimension. Then once an aeroplane is moving like this in the space, people, x, y, z vary. In addition to that, time also varying. Then there are 4 dimensional. Like that, people, we can associate this kind of variations to this case. In that case, people, the number of dimensions will be increasing. People, now we can at least think this 4 what variations now: x variation, y variation, z variation, 3, and the time. Another more variations, that means more dimensions available. You know the Einstein's. So now he can think, of course, about more dimensions than 4. We can't believe that, people. Right? So we don't know, we can't think much. Now we don't know even what are the other dimensions. Now it says he can think more dimensions at once. Variation of something, we know x, y, z, then time, no. Another more what things he considered, right? So I don't know about that, but it says like that. Yeah. Now let's see, people, how to write the position vector of this Q. OQ, position vector in the space. OQ position vector, people, we write like this. This O to P vector, you know, this is y, no, people. This length is y. Then O P vector, we can write x I is this vector. This length is y, no, parallel to j, y j. Then this O P vector going to be xi plus yj. And now this vector we know. What is this vector? From here to here. Is that k? Okay. Then I can write the position vector of q. Write down position vector of q. Position vector of q. Position vector of q, we can write OQ vector. What is that, people? Here, from here to here vector is what? Length is x, unit vector is I, xi. From here to here, yj. Right. So now if I do that one here, this is the point P, this is the point O, OP vector, this is point P. This is xi vector, this is yj vector. Then OP is xi plus yj by the triangle of vector addition. OQ vector I can write later. First we'll write OP vector xi plus yj. Right, now here we have Q, and therefore this is zk vector. Then we need OQ vector. What is OQ vector now? OP plus PQ. OQ vector, we can write OP vector plus PQ vector again by triangle of vector addition. Right? And then we get what, people? OP vector is xi plus yj plus PQ means what? Zk. Then we get the position vector of the point Q as xi plus yj plus zk. Right? Zk. Right, people, this is all in this lesson. As theories we must discuss, but we must do some more sums. I take that time later. Next week we'll start the new lesson, that is the inequality. Okay? Yeah. Any question regarding this lesson, people?